hydrocarbons are compounds that only has carbon and hydrogen atoms. Well, I'm going to explain you the importance of naming hydrocarbons, what is UPAC, and its function. UPAC creates some rules to name hydrocarbons. UPAC is the International Union of Pure and Applied Chemistry. The importance to name hydrocarbons is to identify them because there are a lot of them. The most common hydrocarbon are ethyl, and propane.
There are organic chemistry and inorganic chemistry. This is organic chemistry and it uses carbon, hydrogen, oxygen and nitrogen. Organic compounds are divided in hydrocarbons and hydrocarbons derivatives. Hydrocarbons are divided in aliphatic and aromatics. And aliphatics are divided in alkane, alkene and alkyne. The main difference between them is that alkane has a single bond, alkene has a double bond, and alkyne has a triple bond. These are the steps to name the alkane. First, identify the longest continuous chain. Second, number the carbons of the branch chain. Third, identify the substance, then name the substituent in alphabetical order. If one appears several times, use prefix B, tri, and tetra. And finally, indicate the position, substituents, and at the end of the branch chain. These are some examples. In this example, we need to identify the longest continuous chain. That is this. And then we need to number 1, 2, 3, 4, 5, and 6. The substituents are this. And these are methyl. And there are 2 methyls. And then we need to put the section 2 and 4 B because are 2 methyl. B. And there are 6 hydrocarbons, so this is an hexane. This example is 2, 2, 4, 2, 2, 4, 3 methyl because these are methyl, and pentane because the longest chain are 5 hydrocarbons. And this is 2, 2 dimethyl are 1 and 2 methyl, and propane because the longest chain have 3 hydrocarbons.
Well, at this moment, I'm going to talk about how to write a structural formula of this compound, hydrocarbon. First, we have to identify how many bonds does it have, and the ending is N is going to have single bonds, and then we identify the prefix pent. That means 5 carbons. Well, here we need to identify in what position the methyl is located. Or here we have the position 2, 1, 2, 3, 4, 5, 2, and then here it says methyl, so it will be something like this. This is the substance. And then we have to fill out the hydrogens. To complete the 4 bonds that carbons can have. structural formula of these compounds, 2-methylpentane, and this will be and here we have two more examples, and this is the simplest than this, because he only tells us propane and butane. And these are examples, and this is how to write a structural formula.
Well, I'm gonna tell you the steps to name the alkenes. The first step is identify the parent chain. The next step is identify the bonds. The third step is number the carbon. Start from the ending of the chain. The next step is identify the substituent. The next step is name the alkene. Start from the location of substituent. It's methyl because it's only one carbon. Is pentane. Pentane because are only 5 carbons, and the ending of in because are alkene. These are some examples of alkenes.
Well, at this time I'm going to explain how to write a structural formula of this compound. And this compound refers to alkenes. So we have to identify how many carbons does it have. And then with the perfect spent, we can infer, or we can see that the compound has five carbons. And then, with the suffix in, it tells us that it is an alkene, so it has double bonds. And then this number here, it tells us the position where the double bonds will be. And then the position 1 and the position 3. It has two double bonds in here because the position, and then number 3. 1, 2, 3. Here are the double bonds. And in here we have to indicate the position of where methyl is going to be. So the position 4 is going to be the methyl, the substance methyl. 1, 2, 3, 4. Methyl consists of 1 carbon. And then this is our compound. But we have to fill out the carbons. So and this is our compound with an structural formula. Well, I'm here again, and then I will show you two more examples of how to write a structural formula of alkenes. First, I'm going to write them, and then I will explain it. two examples of alkenes.
Second step is number from the ending closer to the triple bond. So we will begin to numerate. Here, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And after we will locate the substituent, and it will be called methyl, and this ethyl. After that, we will write the substituent in alphabetic order. So it will be 5, methyl, 2, methyl. And after we have to write the number where the carbon is sharing the triple bond. That is in the carbon number 3. And as the parent chain have 9 carbon, it will be named none. And like it is an alkene, we have to write Y-N-E in the end. So the name is 5, ethyl, 2, methyl, 3, nonane. And those are other examples of how to write ten.
Well, I'm here again, and at this time I'm going to explain to you how to write a structural or a condensation formula of the alkanes. Alkane has a characteristic to have triple bonds. Well, yes, that I want to tell you. Good. First, we have to identify how many carbons does it have. With the prefix but, we can see that the compound has 4 carbons. And then, where is going to be the triple bond with this number here? Is the position where the triple bond would be 1, 2, 3. This is a triple bond. And so we have to write the substituent of this one. So 2 ethyl. The position 2, and we're gonna find 1 ethyl. 1, 2. And then in position 1, we're going to find 1 isopropyl. And then we have to follow it up and with the missing hydrogens. Hi, I'm here again, and I will explain you and show you 2 more examples of how to write a condensed formula from alkenes. Sorry. First, I'm going to write the formula and then I will explain you. here we have the two examples, and here we have four carbon with the prefix because of the prefix, and the position here it will be the triple bond. And here we have in the longest chain 6 carbons, and then the position where the triple bond will be 1, 2, 3, 4. And then we have to include the substituents. In the position 2 and 4, we have methyl, and because there are 2, we have to put 3 here. And then 1, 2, and then the methyl, 3, 4, and then the methyl, and this is our 2 examples of alkynes. Hello, we're here again, and then we are going to explain the different ways to write the aromatic compounds. And here we have 3 different ways depending the number of substituents. And we have to with 1 substituent, we have to with 2 substituents, and we have with 3 or more substituents. First, we have to explain the 1 substituent. No numbers needed. First, we don't need numbers. The second, name the first, the substituent, and some have a common name. For example, we have the ring of the benzene, and then because it has one substituent, it isn't necessary to put any numbers here, because the position is whatever, it isn't there. And then we only have ethyl benzene. And if it have a common name, there are 3 common names: toluene, phenol, and another one. And for example, here this is called like toluene. And the second, with 2 substituents. Here we need use numbers in alphabetical order. For example, here 1 and here 2. We need to use the prefix in alphabetical order of benzene, ortho, if the substituents are in the place 1 or 2, meta if substituents are in place 1 or 3, and para if the substituents are in place 1 or 4. In this example, the substituents are in place 1 and 2, so we can use the prefix ortho. Ortho, we write the letter O, and then we write ethyl because we have here an ethyl, and then we write methyl because here we have a methyl, and then the ending benzene. And another one is a common name. Again, if in our compound, if in our formula, we have a common name, in this case it's toluene, and we write the same, but change the melting benzene by toluene, and it is exactly the same. And the third one, when we have 3 or more substituents, we use number in alphabetical order plus benzene or common name. And it is the same with the other ones because it is our longest chain and it's of substituents. Here we have the methyl, here we have the ethyl, and here we have the isopropyl. So in this compound we have to write 2 ethyl because of the alphabetical order, and for isopropyl the same, it would be got to the alphabetical order here, and then 1 one methyl, and then the word benzene. And if we have a common name, we can change it when changing the two words methylbenzene by toluene. And it is exactly the same. And it will be 2-ethyl, 4-isopropyl, toluene. And this is how the code automatically